Okay, so we have a question with a mass that is held in equilibrium by springs, as you can see on the diagram. Please pause this video to read the question. So the fact that it says that it's in equilibrium, that means all the forces are balanced and the object is not moving. So for the first part of the equation, we need to use the Hooke's law. It's giving us the force that is acting on the spring and the extension, and we need to find that the stiffness of the spring is about 2 Newton per centimeter. So in this case, simply we're just gonna apply Hooke's law, which is the force equals the spring constant, which is something that tells the stiffness of the spring, times the extension. So simply we're just gonna substitute the right numbers. We're looking for K for the spring constant, and the extension here is 8. So dividing 15 over 8 will give me the spring constant. So this value will be about 1.875 newtons per centimeter, which is around 2, as the question is asking us to show. Now for the next part of the question, I have copied the image there just to make it easier. Is saying that the mass that I'm putting on the hook over there is 0.55 kilograms, and the value of force P is 85 newtons. Calculate the value of theta and the extension of the spring in the force meter. Now this is a question about equilibrium, static equilibrium. So what we do, we always analyze the forces into x and y axis. So I'm just going to draw the x and the y axis. Okay, so what do I know? I know, of course, P, which is 8.5 newtons, it's given. So I have the weight, and we know that the weight is m times g. So we are given the mass, we know g, so we know that as well. And then the force F can be resolved into F sine theta and F cos theta. So if you look at the resolution of forces, you know, as a rule of thumb, the component that is close to the value, to the angle that we are given, is getting the cos component, and the component which is away from the angle that is given is getting the sine. So this is the 4 forces acting on that string, on that point over there, and since everything is in equilibrium, we can say that on the y-axis it's in equilibrium, therefore F sine theta is equal to weight, and I know that weight is mass times g, so I'm just going to write mass times g directly. And on the x-axis it's also in equilibrium, therefore what's happening on the x-axis, F cos theta is equal to force P. Okay, so we know the numbers there. So F sine theta equals mass times g, which is 0.55 times 9.81. No need for the bracket actually. And then for F cos theta, that will be equal to P, which is 8.5, sorry. Now we have 2 unknown terms. We have the force and they have theta. So two unknown terms, we need two equations so we can have a simultaneous equation system, and then we can find out f and theta. So you can work the f and theta using simultaneous equations, or there's a trick you can do to save some time. You can just divide these two equations by the part of these equations. And what do I get from that? I can cancel out the force, and then I know that sine theta over cos theta, that will give me tan theta. So tan theta will be 0.55 times 9.81 over 8.5. So if I do these calculations, I can get, let me actually do these calculations, so 0.55 times 9.81 divided 8.5. So I am getting something around 32. So I found theta, and now I have to find the new extension. From before we found out, we have shown that the stiffness of the spring constant, it was around 2 Newton per centimeter. So I can either use the value that was given, or I can actually use the value that I have calculated. Whatever you decide to use, it will be correct. And how do I find the extension? If I want to find the extension, I need to use again Hooke's law like before, k and delta x. So I'm looking to find the extension. How do I find the extension? I need to know k, which I do, and I need to know f. So I don't know f at that stage, but what I know the two components that they make f. I know f sine theta and f cos. So in this case, I'm combining vectors, and because the two vectors are perpendicular to each other, I can find f using the Pythagoras theorem. So f squared will be equal to f sine theta squared plus f cos theta squared. Or I can just simply remove that square from there and then put everything else into the square root. So therefore, what is f sine theta is equal to mg, which is 0.55 times 9.81 squared, plus what is f cos theta, that will be 8.5 squared. So by doing these calculations, you will find out that f is around 10 newtons. And then I'm going back to the Hooke's law, where 10 equals 2 times delta x, the extension. Therefore, delta x equals 10 divided by 2, therefore 5. So I have used centimeters as my unit for length. Therefore, the extension will be 5 centimeters. So 32 degrees for theta, 5 centimeters for extension. Remember, if you use that value, you're going to get slightly different answer.